So another aspect of electrochemistry is the idea of mass changes of electrodes. So if we have a traditional setup, typically we have a solid electrode, and in most cases the electrode is what's reactive. So just a refresher, if you have a battery, what a battery typically consists of are two compartments, your anode and your cathode. And these are connected by your salt bridge. Now, within each anode and cathode compartment, you have your anode and cathode electrodes. We represent these with these rods. These are connected by some type of voltmeter, some type of load, but basically we have these electrodes that are participating in reactions. Now, some electrodes, full disclosure, do not participate in the reactions at all. We can have graphite rods that basically let metal plate on them. But typically, especially on the anode side of the reaction where we have oxidation occurring, we see the anode losing mass. And almost always we see the cathode gaining mass. So how do we quantify how much mass is gained or lost on the anode or cathode side? Well, this is actually a surprisingly easy calculation. So let's start with a reaction to kind of illustrate and fill in the blanks. Let's say we have a zinc anode and a copper cathode. We run our reaction and we produce zinc plus 2 ions, copper metal. So this is our copper reaction. And this is our anode reaction. To quantify how much mass is gained or lost at each electrode, the only thing we have to do is figure out how many electrons flow, because this is an electrochemical reaction. So, reason for working this reaction, very easy to see what's going on. We have copper going from +2 to +0. So 2 electrons are transferred between the anode and cathode reactions. Now, the amount of electrons transferred is proportional to the current, represented by the letter I. So our current is the number of electrons flowing from the anode to cathode side, and this is proportional to the extent of reaction. Now, the units of current are a Coulomb per second. Coulomb is a unit of electrical charge. We'll get to that in just a minute. So to determine the number of electrons, first thing we need to do is multiply by the time in seconds. Because this is going to tell us how many coulombs actually transferred from one side to the other. So once we're at this point, once you multiply by time, we're in units of coulombs. Now, a coulomb has a proportionality constant related to the number of electrons, particularly the number of mole of electrons. So if we want to convert from coulombs to moles of electrons, it's just 1.037 times 10 to the negative 5, in this case, moles of electrons per coulomb. So we take our current times our time, multiply by a conversion factor that'll get us to moles of electrons. How do we get to moles and grams of what we're interested in? Well, we do what we do for any reaction. It's where we're coming from times where we want to go. So, if we want to go from moles of electrons to moles of whatever, we're going to divide by the number of electrons transferred in. And this will depend on your reaction. And we're going to multiply it by the reaction coefficient of what we're interested in. So if in this reaction, the simplified reaction, we have zinc and copper, so these are all 1 to 1. But let's say we had a reaction where it was 2 and 3 and 4 and 5. Whatever we want to find, we're just going to multiply by whatever number is in front of it. And this is going to give us, ultimately, moles of what we're interested in. So this is your master formula to figure out moles of anode or cathode that are reacted away. Now you had to make the judgment call. If you're on the anode side, these moles that you're calculating are the moles corresponding to the moles lost on the anode electrode. If you're on the cathode side where reduction is occurring, typically these moles of I are going to refer to the amount of moles that are plated onto that electrode. So how do you actually figure out the mass? Well, this is just a mass to mole conversion. Once you have the moles, use your molecular weight, and that'll give you grams lost or gained depending on when you're looking at the cathode or anode reaction. And in the next video, we'll actually walk through how to do this type of calculation.